Hello everyone, thank you for watching this video in which I will make some clarifications on the OAuth flow that I have presented in one of the videos. So the questions that I've received are in front of you here. I will take them one by one and hopefully I will manage to clarify each of them with a good answer. So first one would say, if I want to have my own users in the application, should I get it done like this? Referring here probably to the OAuth flow. Not necessarily, so the answer would be not necessarily. You can use any kind of approach. If you will take the videos about Spring Security on this channel, you will see that there are multiple approaches, so probably you have only seen one of the videos, that is this one. In this case, my recommendation for you would be to just go to the Spring Security playlist and take the videos one by one in the chronological order I have done them, and you will see that there are multiple approaches, and of course depending on your application, what does your application do, you will find a good approach that could be this one, or could be one other approach that is even easier. For example, just use the plain way of just defining your user detail service, have a database with the users, and then you simply use HTTP basic for authentication. It really depends on your application if you need to use OAuth or not. I can't answer the question, should I get it done like this, if I don't know exactly which is the use case. OAuth is a very good architecture, but of course, as anything else, it can be applied the best on specific situations. When the app will be deployed, there will be two separate servers present on the host. Here I would say like this, again, if you take the videos one by one, you will see first that even with the OAuth flow, there are multiple ways to implement it. So for example, when you say two separate servers, probably you refer to the authorization server and the resource server. And in case of these two responsibilities being apart, then yes, you will have two different applications. I can't say if they are present on the same host. Not necessarily. Usually, you can do this in a containerized environment, and then you have multiple virtual machines, and then you can have multiple pods of the same application that can be spread on different virtual machines, which in a cloud environment would be on different availability zones. So yes, you can add them, you can put them on the same host, but usually I would say that in a practical situation, you would not use the same host for just running both of the applications. When you have different responsibilities, and especially in a cloud environment, you probably would like to have the possibility to scale your application, as well as the possibility to have a good failover. So in case one of the virtual machines have a problem, you need another one to take the same role in order to avoid having bad availability of your application, let's say. So depending on how you implement your application, there will be one or two different applications, so you can have both responsibilities in the same application, or you can separate them apart. And if you separate them apart, they can be on the same host, or they can be, usually they are on different hosts, on different virtual machines, in containers, spread among availability zones in a cloud environment. And then besides that, if I do not have a client name or ID, should I make a DB only for it? I'm not sure if I really understand this question, but then I see just down below, I did not understand what is the client. So let's first clarify what a client is, and then I will try to explain how to use a client. And then if you need to have a database or not, then this is again really depending on what your application is doing. So it's a very, very general question. But I have already opened here, I think it's the same example that I have used in the video that you are referring to, and you are referring to the fact that I'm using here a client, which in this case I have simply stored it in memory, which is an in-memory storage in the application. You will probably not see something like this in a practical scenario. but here, to be easier, I just declare the client ID and the client secret directly in my code as being only an example application. And if you only have one client, then you could actually use the in-memory, and of course then the client secret and ID will be taken from somewhere, never store them directly in the code. And you might need a separate way to store them, like a database usually, if you have multiple. Now, what a client is the third responsibility in the OAuth architecture. The other two responsibilities that I have also mentioned a little bit earlier are the authorization server and the resource server. And the authorization server refers to that application managing the users who is granting the possibility to access the resources, while the resource server is the application holding the resources to which the access is granted by having the authorization from the authorization server. And then the third responsibility is the client, which is the application itself that benefits from the authorization and the resources. So if I would just draw it in a paint, for example, which makes my life very easy to do that usually with this nice tool, old tool called Paint, we can do a lot of things, and you don't need a specialized diagram tool for that. I have here three responsibilities, and then I also have the user here. So this is my user, and my user is actually using an application, and this application can be a mobile application installed on an Android device or on an iOS device, or it can simply be a web page, for example, that JavaScript functionality that is developed using a framework like Angular, React, Vue, that is a client. The application that is directly used by the user, that is called the client. And then of course the user is the one having its credentials. So when the user is using an app, for example this is app 1, then the user credentials are stored and managed by the authorization server. Let's say that it's a username and a password. So when the user through this client wants to access resources in the resource server, they first need to use the username and password to authenticate. So what will this client do? It will actually call first the authorization server, providing the details given by the user to obtain an access. This is usually referred in terms of a token that can be then used to access the resources in the resource server. The resource server is managing the resources which are actually the endpoints that one user wants to access through its application. So again, the authorization server is managing the users and provides authorizations. The resource server is managing the data, and the resources can be seen as the endpoints, the use cases that can be accessed by one that has a proper authorization. To obtain a proper authorization, the client will first ask the authorization server for that. And then the user usually uses directly a client application, which is an application like a web application, for example, the JavaScript part that's using the REST endpoints behind, or it's a mobile application like one deployed on Android and iOS. Why could you have multiple clients? Well, in general, when we look at this diagram, we see that there is only one client. But because of the fact that this authorization server has a transparent responsibility and is not linked tightly to the client or to the resource server, you can register actually one or multiple clients that can use the same authorization server. Like for example, GitHub is doing, where GitHub has some users, but you can register your application as a client application in order to use the username and the passwords, so in order to be granted access from GitHub. You can see one example like this in my single sign-on example is on a video on this same channel. So you can actually register multiple client applications, different applications with different purposes maybe, that use the same authorization server in order to be granted access, and then use the same resource server in order to do some specific business cases. Even if you usually might have only one application in your system, if you develop this, you still have to register it in the server as a client. So that's in my case this client that I have registered here. If I have only one, then I can use an in-memory approach, and the only things that never have to be allowed to be seen in the source code like I've done here are the client ID and secret, which have to be taken from somewhere else. For example, a secret vault, depending on the type of installation of your application. But you can do like this, because in this case it doesn't really make sense to have a database if you know that you actually will always have only one client. But if your authorization server for the future will allow the existence of multiple client applications, then of course the in-memory is not reliable anymore. So then you will probably need to be able to store persistently somewhere your applications that are using the authorization server, the clients, so they are called. So then you will actually have a database probably, and then you will store the client ID and client secrets in the database for those applications that are allowed to use your authorization server. So this is what a client is the application itself, and the application itself has to be authorized separately by the authorization server. So when a user uses this flow, its username and password just refer to that individual. But there is also a client ID and secret used by the application itself in order to authenticate against the authorization server. The application has to be allowed by the authorization server to use its users. So that's why the client ID and secret are the credentials through which the application authorizes itself against the authorization server as being allowed to use credentials of the user. And you can have as many clients as you want for one authorization server. So for example, here the same user would be able to use its username and password, the same username and password, to use the second application, which might have a totally different business purpose than the first application. But both applications authorize using the same server. And in order to do that, both of them have to be registered as clients of this server, and they have to have their own credentials that will allow them to use the functionality of authorization of this server. So that's why we have a username and the password that are related to the users themselves, but we also have a client ID and a secret that are related to the clients, so the applications that use the authorization server. So this is actually how is this working, and I hope this clarifies what a client is. The application itself. The application itself is the client. And then if you do not have a client name or ID, should I make a DB only for it? If you only have one client, as I've said earlier, you can actually directly use an in-memory approach because you have only one. But if you know that in this flow your authorization will actually serve multiple client applications, then of course a better approach would be to have somewhere where you can store them persistently. So probably that the easiest would be here to have a database. To conclude, I will take again each question and just give a very short answer for each of them. So if I want to have my own users, should I get it done like this? Not necessarily. You can use any approach of Spring Security, and I can just again drive you to the other videos so you can see multiple approaches of using the Spring security. It's not necessary to use the OAuth flow. When the app will be deployed, there will be two separate servers, two separate applications. They can be, if you separate the responsibilities, but they can be put into the same applications as well. There are examples on the channel with both the approaches. Present on the same host, not necessarily. You can have them on the same host, but they can be deployed on separate hosts or virtual machines and so on. And then I hope that now it's clear that a client is the application that is used by the user and that has to be registered. If you have only one client, you can use an in-memory approach, and if you have multiple clients, then probably yes, you would need a database to store your client credentials persistent somewhere. I hope this answers your questions and I hope this is helpful. Please let me know if it's still unclear something, if I still didn't manage to cover everything. Let me know, and I'm very happy to come back and re-explain or I don't know, provide a code example if you feel that makes it even better for this part. Thank you very much for listening and stay tuned for new videos.